हो टाकली. आवाज येतोय का? हॅलो, आवाज येतो का? काने काळे.
हो सर यायला.
यस, ओके ओके.
व्हिडिओ दाखवायचं तुमचं.
हा,
तुमचा व्हिडिओ दिसायचा.
हो, राईट. थँक्यू. हो, a very good morning, dear students, one and all. Welcome back again on online teaching, learning and evaluation. As we know, due to pandemic situation, it is again essential to have online classes. And as you already well know, your examination will be held in the form of MCQ. We are discussing about heterocyclic compound in offline theory classes, and up to we have already discussed about what are heterocyclic compounds, how they are classified on the basis of their size rings and their number of heteroatoms present in the rings, as a 5-membered ring, 6-membered ring, condensed, and all these things. Then later on we have discussed about the 5-membered heterocyclic compound, as a pyrrole is one of the 5-membered heterocyclic compound. Their synthesis method, their occurrence, their chemical properties, their physical properties, and their molecular orbital structures. All these studies we already learned. At the same time, we have also discussed about the another 5-membered heterocyclic compound that is called as furan. So this furan is also we have discussed about their molecular orbital picture and all their synthesis method, physical properties and chemical properties. Okay. Now today we will discuss about the another heterocyclic compound, as we already see in the screen. That is a third 5-membered heterocyclic compound which is in your syllabus, that is called as thiophene. Thiophene, which is also known as, for IUPAC nomenclature name, that is called as thiol. Okay, which is already shown in the screen. And this 5-membered heterocyclic compound, which is exactly similar to that of pyrrole 5-membered heterocyclic compound and furan thiamine compound, only in a 5-member, one carbon atom is replaced by sulfur. In pyrrole, we are having nitrogen. In furan, we are having oxygen. Here, we are having only sulfur. Is a one of the heterocyclic compound. Hence, the molecular formula of these 5-membered heterocyclic compound is a C4H4, yes, which can be represented in the structural formula as we already seen in the screen. So that is both the sides we are having one carbon atom, 5-membered ring, 2 double bonds, and sulfur atom you can represent below the ring as well as above the ring. And as we know already, the heteroatom we should give always the number first, and we have also shown the numbering 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 either clockwise or anti-clockwise. So that is the structural formula of the thiophene, which is a IUPAC, it is called as thiol. We also showed the 3D structures, which we already seen in the screen of our laptop. In the screen, that is yellow color is represented yellow bond. Yellow bond is represented as a sulfur molecule, whereas the brown 4 carbon atom can represent it as a carbon atoms, and there is a 2 double bonds and 4 white balls which are attached to that carbon, that is called as hydrogen. So that is a 3D structure we already showed in the screen. And after that, if you know the structure, molecular formula and structure of the thiophene, Then the question is where it will be occur. So, dear students, as we know, already coal tar is one of the source where can obtain the majority of the large quantity of the amounts or the minimum quantity of the amounts of the number of heterocyclic compounds. So, thiophene is also occur in the coal tar. Then we are having the shale oils. Okay, crude oils which are can the black colors which can be shown in the screen. So that is called as the shale oils. Then the rock formed in the thin layers. Okay, in the mountain. So we are shown in the picture. So that is a layers, the colored layers of the rocks, not our in the Marathwada region, but in the rock layers, the colored rock layers. So in that rock layers, we can getting the some parts of the thiophene, which is having the some pleasant smell. So that is a slightly dirty smell. It is shown here resemblance to benzene, but it was having slightly the dirty smell of the thiophene type of compound due to the sulfur. Okay, so this can be three major things where the coal tar, where the thiophene is occur in coal tar, shallow oils, and the rock of the thin layers. Okay, so खडकाच्या पातळ पातळ layers म्हणजे जो असतो colored layers, which are already shown in this one. And then later on, it was in 1832, the German chemist who has whose name is called as Victor Meyer. He was firstly synthesized the thiophene by fractional distillation from the coal tar. Fractional distillation. Fractional distillation, as we already well known about the distillation assembly, there is a round bottom flask, and then round bottom flask we can attach our Liebig condenser, and the Liebig condenser we are having the columns 1, 2, 3, 4 like this. That is called as fraction, just like such steps. Okay, Liebig condenser we already, which already we have already seen in the lab number 5. So there is a distillation assembly, but where the Liebig condenser, where inner surface we are having the clamps like this way, or glass. This is called as a fractions 1, 2, 3. So that will have the different temperature, and outer side we can maintain the water circulation to cool this one, and then we can have the distillation. So this is a simple theoretical diagram I have explained, which already we have seen in the lab number 5, or which can be quoted in the any chemistry books or in the any laboratory journals, which can be market available. So that is called as the fractional distillation. So this was firstly synthesized by the Victor Meyer in 1882, which was firstly synthesized from the coal tar, and you can get very the colorless liquid, very few milligrams or few mLs of you can extract by fractional distillation. So that is having the property of the thiophene. Then later on, the synthetic methods, how you can synthesize. So there are 3 methods as per your syllabus. You have to synthesize the thiophene from the acetylene molecules. Acetylene, the 2 moles of acetylene pass through with H2S gas in presence of alumina Al2O3. We obtain the 5-membered heterocyclic compound containing 4 carbon atom, 4 hydrogen atom, and having sulfur atom, which can be shown in the structure. So that is called as the thiophene. Means thiophene, how will obtain from acetylene molecules? 2 moles of acetylene, CH triple bond CH plus H2S in presence of alumina Al2O3 as a catalyst, as a red hot tube. You can just hit the temperature, both this acetylene gas and H2S gas in a red hot tube, and in presence of alumina, you will obtain the colorless liquid. So that colorless liquid is nothing but that is called as the thiophene. Then the another method, which is called as succinamide, means thiophene we can also prepare from succinamide. Succinamide, that is CH2COONA, CH2COONA plus CH2COONA in presence of phosphorus trisulfide, P2S3, as a hot distillation, you can obtain the thiophene. And third reactant, third preparation method from N-butane. N-butane, that we already well know the structure, N-butane, CH3, CH2, CH2, CH3, N-butane, and 4 molecules of sulfur at a very high temperature, above 500 degrees temperature, you can pass through in a red hot tube, you will obtain the thiophene molecule. So these are the 3 synthetic methods. Okay, we can prepare theoretically, or you can, it is a practically you can prepare by the different scientists. So our question is, nobody can ask in the reaction, how just, but what type of question will ask on this type of reaction? They will give the either complete the reaction, acetylene treated with H2SO4 question mark. So your answer must be thiophene. They will give thiophene, furan, piperidine, and like this type of questions are there. Or which is the starting material for preparation of thiophene will used. Okay, they can give acetylene, sodium acetate, then butane, or all the above. Your answer must be all the above. Or they can give only one acetylene, rest of the options are different. So you can ask the question to the reaction, what type of questions will be asked. Okay, so that will be easily understand this one. Then the physical properties, as we know already, all 5-member heterocyclic compounds, they are colorless. But due to oxidation, pyrrole will become slightly greenish colors. Okay, slightly dark in color. And then second point, most type of question will be asked in the examination, which is the boiling point of thiophene. So that boiling point is 84, whereas furan boiling point is 32, whereas pyrrole boiling point is 131. Means these are the three different boiling points. One of them boiling point question may be asked because of to have to confuse the student. So you can easily remember the furan 32, then thiophene 84, whereas pyrrole is 131. So these are three boiling points. If you see the slides, okay, already we have given the notes and slides, all the PPT with you. So that's just you can see the PPT, read it carefully, so they can easily remember and you can give the correct answer of the particular boiling points. Okay, all this is thiophene is also insoluble in water. Okay, thiophene is also insoluble in water. Hence, it can be easily soluble in an organic solvent. It can easily soluble in an organic solvent. Then it can have the resemblance smell with the benzene. But I already told this is benzene is slightly pungent, but it has slightly to have the dirty type of smell due to the sulfur. So then it is stable in aqueous acid and does not show the basic property. This type of question may be asked in the examination. Which of the following heterocyclic compound it shows basic property? So that they can give the name either common name or IUPAC name. So they can give the name azole, they can give oxal, they can give thiol. None of these. So your answer must be azole. Azole means pyrrole. Pyrrole shows basic property. They can ask river questions also. Which of the following compound does not show basic property? So your answer must be either furan or thiophene or both. What type of options are there given? So you can give the same type of options. Okay. Okay. Then after getting the chemical properties of reactions, that is called as electrophilic substitution reactions. As we already learned, almost all electrophilic substitutions, they are resemblance to each other, means they are same. All type of electrophilic substitution reaction, we obtain the two substituted products. That is a 2-nitropyrrole, 2-nitrofuran. Here also same type 2-nitrothiophene, means pyrrole on nitration reaction. That is a mixture of acidic anhydride and nitric acid to obtain 2-nitrothiophene. That is called as nitration reaction. Okay, so they can give the complete the reaction. They will give thiophene plus HNO3H2SO4. What will be the products? Or they can give us the theoretical reaction also. Pyrrole treated with nitric acid and acidic acid. Which of the following product is obtained? So they can give 2-nitrothiophene, 3-nitrothiophene, both, none of these. Your answer must be 2. Why 2? All these things we already explained. Because of 2 position, we are having 2 carbon number, we are having more electron density, and due to the presence of more electron density, it will having maximum electron less. That is electrophile NO2 positively charged, which are having the more electropositively charged. They can easily attach their formation of sigma complex and elimination of proton, and you can get the products. We already learned the mechanism also. So here only the 2-nitrothiophene is obtained. Okay, means you can remember, already we remember the thiophene name. We remember just only 2 position, 2-nitro, and you can just a sense of, you can remember the reagents. Which of the reagent is used for nitration reaction of thiophene? So your answer must be acidic anhydride and acetic acid, or another reagent is also given, that is called as acetyl nitrate, CH3COO-NO2. So this one is given. At the same time, we are having also Friedel-Crafts acylation. Thiophene on treatment with acidic anhydride in presence of Lewis acid like SnCl2, ZnCl2, AlBr3, whatever it may be, so that you can obtain the obtaining product is a 2-acetyl thiophene, which are shown in the reaction. We see the slides carefully. We already given PP to you. You can see the slides and you can easily obtain. Okay. At the same time, the same type of reaction that is called as sulfonation. Means sulfonation, thiophene on treatment with H2SO4 in presence of a strong electrophile that is called as sulfur trioxide, SO3. You obtain thiophene to sulfonic acid. Thiophene to sulfonic acid. 2 position, that is the SO3H is obtained. Okay, so it is called as a obtaining product is called as 2-sulfonic acid. Okay, then we are having N-butyl lithium. N-butyl lithium. This type of a question is already asked in last year. May be possible, which are shown in furan also. Means thiophene on treated with butyl lithium, CH3CH2CH2Li, butyl lithium in presence of dry ether, you obtain 2-lithiothiophenane. There also 2-lithiopurane is obtained. Okay, so just obtaining product is a 2 position, and you can already well know the substituents, which is electrophile at 2 position. You can very easily obtain this one. Then this is the unique reactions which can only obtain in a thiophene. So that is called as chloromethylation reaction. Chloromethylation reaction means a thiophene on treated with formaldehyde in presence of strong acid HCl and the Lewis acid as a catalyst to obtaining the product that is called as chloromethyl thiophene. Means not 2-chloro, it will 2-chloromethyl. If you see the structure, thiophene ring, then attach CH2Cl. So that is called as 2-chloromethyl thiophene is obtained. This type of confusion question is not asking. So thiophene on treatment with aldehyde and HCl. Normally we are obtaining the 2-formyl thiophene, 2-formyl pyrrole. But here we are obtaining the 2-chloromethyl thiophene, CH3 thiophene, CH2Cl. So 2-chloromethyl thiophene obtained. So this is a unique reaction. You just remember this one, not 2-chloro, but this one. Then 2-iodothiophene means on iodination reaction, thiophene on treatment with iodine in presence of mercury iodides, mercury oxide, HgO, mercuric oxide as a catalyst. So you can obtain 2-iodothiophene. Normally, when iodination in pyrrole, we are getting tetra, but there is no catalyst. Here you can use a specific catalyst at controlled condition, mercuric oxide. So you can obtain the 2-iodopyrrole. Then the another also the unique type of reaction that is called as the mercuration and demercuration reaction. So it means thiophene on treated with mercuric chloride in presence of sodium acetate to obtain 2-mercuric chloride thiophene. Thiophene HgCl. So this is only the 2 reactions which are different than pyrrole and thiophene. That is a 2-mercuric chloride thiophene. Means thiophene HgCl. 2-mercuric chloride thiophene, and here we are obtaining 2-chloromethyl. Then reduction is a common, which can be hydrogenation reaction, that is called as platinum or palladium or nickel catalyst. We obtain the tetrahydrothiophene. Means all double bonds will convert into single bond. Means sulfur CH2. Yes. So that is a C4H8S. That's type of structure. Ring is obtained. That is called as tetrahydrothiophene. hydrothiophene. Okay. These are the chemical properties which are having called as electrophilic substitution reaction. You just see the reactions, products carefully, you will obtain this type of reactions. Okay. Now we are having another heterocyclic compounds that is called as six-membered heterocyclic compounds. Six-membered heterocyclic compounds is only one heterocyclic compound in our syllabus that is called as pyridine. Pyridine, which is a IUPAC name, it is called as azyme. Dear students, there will be definitely one question, IUPAC name of heterocyclic compounds. So five-membered azole is a pyrrole, oxal is a furan, thiol is a thiophene, whereas azyme is a pyridine. Which of the compound shows the following name? Okay? Which of the compound having azyme as a one of the heterocyclic compound? So they are given the name pyrrole, thiophene, furan, pyridine. So azyme is a only six-membered heterocyclic compound is commonly called as pyridine. Pyridine is just such a useful reagent which can use in the laboratory for different catalysts for carrying out the different reagents. As azyme is a IUPAC name, then it's having the molecular formula that is which already shown in the screen. So that is called C5H5N. C5H5N, which is a exactly resemblance look like to benzene, but there is a one carbon atom is replaced by nitrogen atom. Okay, nitrogen atom. That is and always you have to give the numbering heteroatom first. 1, 2, 3, 4, 5, 6. That is called as the azyme. Okay, which can be also shown here. We can have this 3D structure. 3D structure in the dotted. There is a benzene ring like this one blue color that is called nitrogen atom. Then 5 hydrogen atoms is attached, and this double bond which is shown in the form of dotted line, which already shown in the screen, that is called as a 3D structures. Then occurrence, where it will occur. So as you already well known, coal tar is such a type of raw material you can obtain number of heteroatoms or heterocyclic compounds. So here coal tar is one of the source we can obtain this 5-6-membered heterocyclic compound that is called pyridine. Then it can be easily obtained from the bone oils. The animal bone oils, they can obtain the pyridine, this one. Then along with pyrrole bone oils, along with pyrrole, one of the 5-membered heterocyclic compound, we can already obtain this one. Then most of the source that is called as several alkaloids. Alkaloids, tomorrow we will discuss the another chapter, alkaloids. So alkaloids are nothing but they are alkali-like substances which can having natural sources which can be used as a, all alkaloids are poison, but they can use a small quantity just like as a drug, which is very useful. So just here we have shown in this picture that is called as affine, okay, morphine, codeine, ephedrine, several the natural alkaloids, nicotine. So these are the pyridine you can obtain from, these are the sources where we have shown in this picture of the slides. Okay, so pyridine is as we know already abundant in the nature, but we already explained these things. That is we are using a daily life trace amount. Pyridine is a volatile organic compounds which can be produced. The roasting for canning the process and roasted the coffee, potato chips, and sunflower honey. Means this can be very useful for the roasting process or canning the process of roasted coffee, whatever the market coffee is available, or potato chips or the sunflower or honey. So this can be used. So from these sources, what type of MCQ will ask? So they will ask which of the following most of the reagent we can obtain pyridine as a heterocyclic compound. So they can give the answer alkaloids, bone oils, or coal tar. Okay. Then question if you carry most, so you can answer must be the alkaloids. Okay. What type of options are given? You can read the questions very carefully, then think it over for half a minute and then give the answer. Do not be blindly tick mark or do not be blindly the circle become a dark. Okay. you read it, or for reading and understanding. What is necessary? It is necessary to have to see the all the PPTs, listen the videos, attend the lectures, and carefully. If you have spent daily 1 hour at the time of evening, you will get the 100% mark in the MCQ. Just like one day you can see the one PPTs. Second day, another PPTs. Means you are handling mobiles. Okay. Already as I explained, because of without handling all, everybody have the Android mobile. But what type of use you must be used? This already ready-made material with you. I have already given MCQ. Again, 1 to 3 days, I will give again the MCQ. But that is the material with you. Question arises that you must read that.
Lecture.
Yeah. You must. Yeah. What is the question? Shruti. So you must read that carefully. Then you will have the understanding all these things. Okay. Then another point that is called as synthetic. Why I am hurrying? Because of there is no any detail. Just a MCQ type of questions answer. Already material with you. What type of question and how, where is the importance? So that I will explain here. Okay. So synthetic of pyridine. Synthesis of pyridine. There are again 3 methods which can be same type. That is a acetylene molecules. 2 moles of acetylene. In thiophene also 2 moles of acetylene. And there is a only sulfur. Here we are having only one extra reagent, 2 moles of acetylene on treated with hydrogen cyanides, hydrogen HCN. Okay, or acetyl hydrogen cyanide HCN. Just heat, you obtain the 6-membered heterocyclic compound containing 6 carbon atom, 5 hydrogen atom, and 1 nitrogen atom. In the ring, the structure, the resemblance to like benzene. So that is called as pyridine. Means pyridine on treated with 2 moles of acetylene and hydrogen cyanide, you can obtain the pyridine. Then pentamethylene diamine. Pentamethylene diamine. Pentamethylene diamine means NH2, CH2, CH2, CH2. Sorry, one. Hello. घरी नाही पाठवलं कोण पाठवलं त्याला व्हॉट नॉनसेन्स आला असा सही बॅग आला नॉनसेन्स माहिती नाही कोण बोलवलं नाही त्याला NH2 CH2 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 NH2 okay the pentamethylene diamine there is a 5 methylene group CH2 CH2 we can show in the structure and 2 NH2 groups at 2 carbon, 2 end of the carbon, CH2, 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 NH2. So that is called as pentamethylene diamine. Just on heating, it will obtain the piperidine ring, and on piperidine ring, just for the dehydration, will obtain as a catalyst palladium in presence of H2SO4 dehydrating reagents. So dehydration is removal of hydrogen molecules, removal of water molecules, dehydration. Okay, then you can obtain the pyridine as a ring. Pyridine as a ring. So that is the pyridine. Okay. Then third one, beta picoline. Beta picoline, which is exactly the pyridine structure. Only at 3 position we are having CH3 groups. We are having CH3 groups. So it has another chemical name. You can also call the 3-methylpyridine. This is called as beta picoline. So beta picoline on oxidation, it will convert nicotinic acid. Means CH3 group will convert into carboxylic group COH, and which is having on strong alkaline hydrolysis like NaOH or KOH in presence of calcium oxide to obtain the pyridine. So these are the 3 synthetic methods you can prepare the pyridine. Just what type of question here asks? Which of the following reagent used for synthesis of pyridine? So the answer must be pentamethylene diamine if it is given. If it is given beta picoline, it will give beta. Okay. Or they may be having one type of confusion question. which of the intermediate product obtained in synthesis of pyridine? Nicotinic acid, narcotinic acid, or piperidine? So your answer must be from nicotinic acid or piperidine. This type of question will be one extra question, such type of confusion question will be asked in the examination. Okay. These are the molecular orbital pictures, as it is exactly similar to that of pyrrole, only the 6-membered ring. Physical properties, which is same, boiling point 151, 115 degrees centigrade, miscible with water. It is hygroscopic in nature, soluble in organic solvent, characteristic smell, pleasant smell, shows in basic property. Pyrrole and pyridine, only two heterocyclic compound, shows the basic property, whereas thiopine and furan does not show basic property. Okay, then from in this picture, what type of question always asked or will be asked? How the bonding structure, how the molecular bonds are obtained in pyridine molecules, sp, sp2, sp3, spd. So your answer must be the bonded molecule in pyridine or in pyrrole or in thiopine or in furan. Answer must be sp2, sp2 hybridization. Okay, from this is only one type of question is asked. Okay, if you see the structures in the slides carefully, we already explained this one, upper lobe, inner lobe, all this we cannot explain here. Okay, then this is most important, electrophilic substitution reaction. In 5-membered ring, we are obtaining 2 substituted products, but in pyridine is a slightly difficult. In pyridine, we are getting electrophilic substitution reaction at 3 positions. Okay, 6-membered, 3 positions. 5-membered, 2 positions. Why? Because of 2 positions in 5-membered ring is more stable, more resonance, more electron rich, more electronegative, and therefore attractive. In pyridine is a electron withdrawing group. Nitrogen atom in the pyridine is a electron withdrawing. Hence, 2 position will be slightly less stable, and 3 position in a pyridine, more electron density is available. And that's why coming electrophile will occur at 3 position. If you see this picture, in this picture, attack of electrophile Y at a different position. In the first reaction, if you see, first reaction, if you see at 2 position, we are obtaining only 2 resonance structures. Resonance means delocalization of pi orbital from one place to another place. 2 pi bond will goes to 1 or 2 position, one place to another position. So that can obtain very less stable. Okay. At 3 position, if you see, therein obtain 3 resonant structures. Okay, which can shown in the green color. So that's why 3 position, 3 resonant structure, 3 is a more figure than 2. Okay, and that's why 3 position, more electron density is there, and that's why positively charged coming electrophile will occupy at 3 position, and hence we obtain in pyridine 3 substituted products. 3 substituted products. It means pyridine on treatment with nitration, your answer must be 3 nitropyridine, not 2 nitro. Okay. Sulfonation, 3 sulfonic acid pyridine. Pyridine, 3 sulfonic acid. 3 position is most important. Okay. Why this one? This is the reason. 4 position also the same, which are less stable. Okay. What is the probable mechanism? Okay. This one first step, attack of electrophile. You can obtain this one as an intermediate condition that is called as sigma complex, and then elimination, which can show this is Y and Z general formation of electrophile Y, formation of sigma complex, a loss of proton to form stable. What are the Y is equal to NO2, SO3, and Br. These are the positively charged electrophiles. Okay. Say this one. Okay, this is the electrophilic substitution reactions. which is the BPC, here same type of reactions. Nitration, 3 nitropyrrole. Sulfonation, pyridine, 3 sulfonic acids. Then it is a unique reaction, that is called bromination. In charcoal, you can get 3 bromopyridine and 3,5-dibromopyridine because of bromine act as nucleophile as well as electrophile, Here, N-butyl lithium. This is the confusion question. Pyridine obtain N-butyl lithium. You obtain 2-butyl pyridine, not 2-lithio. Lithio is the electrophile here. Here, butyl is acting as nucleophile, and hence why it will obtain at 2 positions, and you can get 2-butyl pyridine. Okay, understand this thing. In pyrrole, thiophene, or furan, you are getting 2 lithio, Li positively charged, and they will attack 2 lithiopyrrole. But in pyridine, 2 positions are electron deficient, slightly less, and that's why nucleophile, butyl ring, nucleophile, CH3, CH2, CH2, CH2 negatively charged will attach, and you get 2-butyl pyridine, not 2-lithiopyridine. This type of confusion MCQ will definitely ask in the examination. So you can well remember, when 6-membered, 2-butyl, when 5-membered, 2-lithio. Okay, 5-membered, 2-lithio, 6-membered, 2-butyl. These are the 2 words you can. Okay. Then another one, this is a common perbenzoic acid. You can obtain the pyridine oxide, peroxide, and in presence of hydrogen and sodium ethyl, you will obtain the pyridine. That is called reduction reaction. Pyridine, only all double bonds will convert into single bonds, and nitrogen atom will attach this one. Okay, and then one unique reaction that is called as potassium hydroxide, KOH, will obtain the pyridol. This will be asked in the examination MCQ. Pyridine on treated with potassium hydroxide, what will the products, or how will obtain pyridol? So pyridol is pyridine at 3 position. We are having OH, so that is called as pyridol. So these are the only 2 unique reactions which can be shown. Rest of that 3 positions which are the common. Okay. Then the basic property I already well known discussed. Okay, at 2. Then pyridine also shows nucleophilic substitution reaction. Okay, pyridine also shows nucleophilic, means pyridine at 2 position you can attach nucleophile. Nucleophile means nucleus loving reagents which are having negatively charged, electron rich, means while delocalization at carbon number 2 will become the positively charged, and 3 position negatively charged. So negatively charged, we can attach positive charge. Here 2 position slightly electron deficient because of electron withdrawing group is there, and that's why 2 position is more stable, and hence nucleophile negatively Y charge will attach at 2 position. Okay, and there is only one reaction, so that is called as amination reaction. That is called as amination reaction or Chichibavin reaction. Means this was first by the German chemist who has shown this type of reaction. Okay. This one, nucleophilic substitution reaction. This is the scientist Chichibavin. So when pyridine treated with sodamides, strong nucleophilic reagent, sodamide, NH2 as a nucleophile negatively charged, whereas sodium as an electrophile, sodamide, directly attached goes to the nucleophilic substitution reaction. You obtain 2 position and small amount at 4 position. So you can get this type of reaction. Means here I show general mechanism. NH2Y at 2 position, you obtain intermediate product like a sigma complex, and you obtain the Y as a third substituent products. Here exactly the reaction mechanism I have shown here. So that is a NH2 attack at 2 position. you get this type of intermediate, and then you can abstract the proton NH2, and then lastly you get the eliminate the proton, eliminate this one, and you can obtain the 2-amino pyridine, means 2 position. Pyridine on treated with sodamide, your answer must be 2-amino pyridine, not 2-sodium pyridine. Because of NH2 is a nucleophile. This is the overall reaction. This reaction was firstly shown by the Dr.Subhash scientist, and hence this reaction is called as amination reaction, or it is called as Dr.Subhash reaction. Pyridine on sodamide NH2, you obtain the 2-amino products. Okay, so this was the pyridine 6-membered ring. This is the mechanism. How this mechanism? NaNH2 will form the generation of nucleophile, similar generation of the electrophile. Then formation of an carbanion ion, it is called as anion formation. Okay, so this is a carbanion, it's an anion formation. Pyridine attack at 2 position, it will form anion. It is a highly unstable compound, and their loss of hydride ion, hydrolysis with the help of water to form water molecules, and you can obtain the amino compound, 2-amino compound. So this is about the heterocyclic compound, condensed heterocyclic compound, which we have omitted from this year new syllabus. That is a indole and scarf synthesis we can have eliminated, means only 5-membered heterocyclic compound and 6-membered only 1 heterocyclic compound, that is called the pyridine, pyrrole, thiophene, and this one. And from this heterocyclic compound, there will be definitely 9 MCQ will ask in the examination. Okay, 9 MCQ on this heterocyclic compound. Okay, IUPAC name, what type of MCQ? Already I have given points, MCQ, all these things. Only question is that you should read it carefully. Okay, you should read it carefully and remember it. So chemistry is a volatile subject. It can be easily understood while reading, but after some time it can be eliminate from your mind. So revision and revision mostly important. Okay, with this today we will stop. If you have any difficulty, you can on your speaker, ask me, so I will explain here. So we are having again 5 minutes. You can ask, unmute your speaker and ask. Kane, if you want anybody, Srinivas, Shinde, any type of question about, you can ask. Unmute your speaker and ask. Anybody? Yes. Shinde. Srinivas, Munde पाटील. मला एवढे नाव दिसतात ते फक्त मी घेतो. बाकीच्यांना कोणाला विचारायचे प्रश्न, they can ask. No question. या हो किंवा नाही काहीतरी बोला की. हॅलो.
नो सर.
नो, अरे काहीतरी खोले. मिस साक्षी, ask any question.
नो सर.
नो सर. अरे अभ्यास कसा करायचा, प्रश्न कसे, काहीतरी समथिंग यू कॅन आस्क. Okay, I think then I will stop. Okay, I will stop. If you have no question, tomorrow we will discuss another chapter. Okay.